Have you ever seen a piece of fruit rot? It doesn't happen all at once, it spreads. One rotting spot infects the area around it, and that infection keeps spreading outward. Step by step, minute by minute, one rotten orange or one rotten fruit can spread its disease to the next one. And today we'll be solving a pretty similar situation but with code. We'll be solving the rotting oranges problem, the LeetCode 994. And basically this problem is pretty much what we just described it. Imagine a box full of oranges. If we have one root orange, that one root orange will spread the disease to all the oranges inside that box. And we'll be solving that using code. We'll be learning about different algorithms and data structure. We'll be understanding its trade-offs, and we'll be doing the most optimal solution possible for this challenge. And it's important to mention that this problem, it appears a lot on interviews, especially coding interviews at places like Uber, Meta, Airbnb, Google, and so on. So it's a pretty good problem, not only for passing interviews, but also for understanding and going deeper into algorithms and data structure. I'll be first showing you the problem, understand how to solve that, how to think that in a way that will make you click on your next interview. And then we'll be actually doing that into code, actually writing the code, and I'll be using JavaScript for that. Okay, so basically here I already wrote the description of the problem. So we'll be receiving a grid, like we will be writing a function, and that function will be receiving a grid. And what is exactly a grid? So basically a grid is like a matrix, like a mathematical matrix. So it's basically an array, and inside that array we store the values of the rows and the columns. So it's an array with arrays inside of it. You can think sort of like that. And we'll be receiving a grid 3 by 3, in other words, 3 rows and 3 columns. And inside each one of those rows and columns we'll be having a value. And that value is super important because it can be either 0, which is an empty value. So 0 just means there's nothing, there's no fruits inside of it. 1 means it is a healthy, a fresh orange. And 2 means this is a root, it's a root orange. So it's important to keep track of that. Okay, so for this situation we have like a box with a 2 orange in here, 1s, and the 0s are empty. The goal of this challenge is to understand and count the minutes until all oranges are rot. Okay, so we need to first understand like the spread. So that's a 4-directional spread. Okay, so for example here at 2 we'll be checking its adjacent values. Adjacent here I mean like its neighbors. So for example the position it to the right, to the left, to the top, and so on. Okay, and for that we'll be using code. We'll be learning which algorithm we'll be using to solve this problem, and we'll see that it's pretty straightforward once you first understand this. This is considered to be a medium LeetCode problem, but it helps you, give you some foundations to more advanced, hard and expert type of LeetCode problems. Okay, so the first thing that I'm gonna give to you and show to you is how that is going to happen. So I have here all the minutes. Okay, so remember that we need to count the minutes, or in other words the levels, until all until all values are numbers 2, or they are root oranges. Okay, so we start here at 0, and the first thing that we'll be doing in that algorithm is actually having how many fresh oranges do we have. So we're just doing a loop, and that loop will be inside another loop so that we can get its index, and we'll be just counting how many fresh oranges do we have. And we also going to store the position of the root orange as well. So the first thing that we're doing is actually mapping and checking like, okay, we have the fresh oranges and we have the first position of the root orange. Okay, so that's minute 0. We made the first interaction. And once we start looping and like making sure that the values are actually converted, or they are infected to rooted, then we start to count. Okay, so we start a variable like minutes to be 0, And the first time that we actually go through its adjacent values and make that first level of interaction, we sum that to like a +1, okay? So the minute one, we actually now we spread the disease. We infected its neighbors. So now 0,1 and 1,0 are now infected. They were previously ones, now they are both 2. So that's the first level. So we just sum that to 1. Now we go to the next level. Now we're gonna be infecting the other ones. So here was 1 and 1. Now they're both infected, okay? And we keep track of the fresh count, all right? So we'll be summing and also subtracting from the fresh count, okay? And we keep track of the new currently routing, all right? So we started this as 0 and 0 because that's the first index of this routing orange, but then we keep track of all the routing oranges that we have, all right? And we'll be doing that until all the values possible here are routing, all right? So until so fresh counts needs to be 0. We don't need, we can't have any more fresh oranges inside that box, all right? What happens if we cannot like make all the oranges in their routing? So basically we just return -1. So here I have an example. So imagine you have like an island inside here. So you have another matrix here. We have the 2, 1, and 0. For this one is fine. We can actually make this position root. So this orange can get root, but this one it's not possible because we cannot achieve that. We cannot traverse. We cannot move into this last node that we have in here. All right, so this island cannot be reached. In that case, we just return -1. So how do we actually solve this problem? How can we take all of that information that I just described it to you and make that into code? Well, we'll be using breadth first search. Breadth first search is just an algorithm, just like depth first search or grid. It's just a pattern in which we can use and apply into those problems, okay? We'll be focusing on breadth first search today, but my goal is to be giving you guys more and more data structure and algorithm solutions, all right? So breadth first search is basically a way that we can spread through that matrix and try to collect as much information as we can. So here I have a pretty simple example, is that an algorithm explores node level by level, like ripples spreading in water. So ripple is basically when you throw a rock into a river or a lake and the waves just spread. The same thing happens with breadth first search. So our goal fits exactly that. So that algorithm fits exactly what we need. We start here at 2 and then we go and spread to its neighbors, all right? And here I have some interesting notes. So it's pretty common to mismatch breadth first search with depth first search. There are some key differences. I just want to highlight you why we'll be using the breadth first search to solve this issue and not depth first search, okay? So breadth first search basically use a data structure called Q, like a FIFO, so a first in, first out algorithm. And the depth first search uses a stack, last in, first out, okay? The breadth first search actually goes through all the values. So here you can see the order in which it goes. So it starts with 1 and just spreads trying to get as much information or values as possible, while the depth first search will choose a path and go its own way and then going back into its starting position. So as you can see, there's no much sense in going into only one direction then going back. It really makes more sense that we can just spread that disease. And when you think about spreading, in that context, it's really about breadth first search. Okay, here you can see a few cases in which breadth first search appears a lot. So shortest path in unweighted graph, level order traversal, finding minimal step, distances, problems involving waves or time. So our case fits exactly that pattern, okay? So with that in mind, I want you to just focus on one more thing. So remember that we'll be using a queue. We'll be storing the values. So we'll be storing, for example, the minutes, we'll be storing the fresh count. And just want to mention you that we need to actually have another variable. That variable will be the directions. So as we spoke, we'll need to find its adjacent values. So for example, you are on the position as we spoke here, 0 and 1, we should also be able to find its neighbors. And for that, we'll be saving a variable, for example, call it directions, and we'll be having like up, down, left, and right. So -1 and 0, 1 and 0, 0 minus 1, 0 and 1 for its correspondent positions. All right. So with that in mind, all we need to do right now, it's pretty straightforward. We're gonna first of all loop through this array, find all the fresh oranges, find the first root in position, save that into a queue. This queue will just be an array. We'll save the index of that position, and the fresh count will be how many fresh oranges do we have, all right? And once we have that information, then we can actually loop, and until we have fresh counts, we will be keeping looping, okay? So until we have something on this queue, and until we have fresh counts, we'll still be looping and trying to find a way to route all its values, okay? And we'll be keeping tracking of each iteration by summing that into minutes, all right? So with all of that in mind, maybe that was too much information. Try to pause, like check a little bit about breadth first search, but it's basically that. And you see like on code how much easier that actually is. Now that we understood basically all the concept that we need to start coding and building this project, like giving life to this algorithm, let's just dive into the code and actually start developing it. I just copied the main notes in here. So basically like the 0, 1s and 2, what those means. And here we have 2 different grades. So those are the grades that we'll be testing. For this one, we should return 4. Why 4? Because it will take 4 minutes to complete this entire iteration that will route all the oranges inside here. So the first step is routing those ones, then those ones, and to this last one value. On the other hand, this one should return -1 because here we have an island. We have this wall of zeros, and this will prevent us from going into here. And you see how easy it is to actually build and solve this medium LeetCode problem. Okay, so the first thing that you'll probably be asked to do in an interview is to create the function itself. I'll be calling this one oranges routing because we are at a process of routing all the oranges inside of this matrix. Okay, and here we'll be receiving that grade. Okay, now the first thing that we need to establish is to know how many rows and columns do we have inside that grid. For the rows, basically all you need to do is just go here and take the grid.length. Why grid.length? Because the grid.length basically means that we have, for this case, 3. The length of this grid, we have a total of 3 rows. We have 1, 2, and 3. And we also need to have the total columns inside of that grid. So just gonna do the grid dot under position 0 dot length, just like this. So here we have a 3x3 matrix because we have 3 rows and 3 columns, as you see in here. And as we spoke, we'll be storing the values of the routing oranges, the position of those routing oranges inside a queue. Okay, so we can name this as queue, and that would be just a plain array. And we also gonna save all the fresh oranges that we have. Okay, the fresh oranges will be 0. The first thing that we need to do then is, since we have that base case, we can now iterate and save those values inside that queue and fresh oranges so that we can then use the breadth first search algorithm to perform and check the values. All right, so the first thing that we'll be doing here is creating a for loop. I'm gonna call this R because it's gonna be rows, and as long as R is less than rows, I'm just gonna sum that up, and I'm gonna do the same thing for the columns. But why am I doing this? Why am I iterating through both cases? Mainly because what we need to do is check each value inside of that grid. So the first loop will iterate through those rows, and that other loop will iterate through the values inside of that column, okay? We can get a current And that current will basically means that we are on the grid on the row R and on the column C, as we have in here. And now all that we need to do is check if this current is equal to 2, that means we are on a routing orange. In that case, all that we need to do is add that to that queue. So by passing the current row and column, we save that. So for this case, for both cases, that's gonna be 0 and 0 because we found a current that is equal to 2. If that is equal to 1, if current is equal to 1, then this means this is a fresh orange, and then we can just sum that up in here. Okay, so with that said, we have the most important information needed to actually check and make sure that we are routing all the oranges. Okay, now one thing that is really important is that we need to save the directions. Okay, so as we spoke, the directions will help us go through the next node inside that matrix. Okay, here we can map that like this. So basically we need to go up, down, left, and right. And in order to go up, all that we need to do is move to the row -1. So let's suppose we are here at 0. We're not moving left or right, so we're not moving inside the column, we're moving in the rows. So for instance here, -1 will move us up and 0 will keep us where we are. Okay, so that's up. We can do the same thing for bottom. Bottom would be basically 1 and 0 because we are moving through the row but not on the column. The same thing will go for left and right. Okay, so 0 minus 1. 0 minus 1 will make us go left, and 0 and 1 will make us go right. Okay, -1, let's suppose we are here at 0, we go -1, we'll be here. If we go 1, we'll be here at the right position, right? Now, what we need to do is actually now have the minutes. So the minutes, it's actually what we'll be returning. So minutes is gonna be equal to 0. And later on, of course, we'll be changing this, but basically minutes is what we need to return, since we need to return 4 on this case. Okay, now here is where it all starts with breadth first search. So all we need to do for now is actually do a while loop in the queue. So as long as we have something on that queue, inside that queue, in that queue, we'll be iterating over and over again. And so while we have something, so for instance, we start with something, we have the queue here, and the queue will have, on that case, 0 and 0, okay? Now with that queue in mind, the next thing that we need to do is actually loop through that queue that we have. So we can actually call this size and get the queue length. And we can now do a for loop using I here. So as long as I is less than size, we're gonna loop inside this for loop that we have, okay? Now, the other thing that we need to do is get the first position on that queue. So remember that queue is first in, first out. So the first value that we stored on that queue is the first value that will be retrieving out of that. So all that we need to do right now is getting the queue dot shift. That shift that's gonna get us the value that we need. Okay, now with that in mind, we can destructure that and actually get the values that we stored. Since we stored an array, we can actually get the row and the column from that. So we can get row and column from inside here. Now, what we next need to do is do another for loop now with the directions, because we need to loop through all those 4 positions that it's possible. For let's suppose here we are in 0, we need to loop and check all possible combinations here and see if that is valid or not. Okay, so I'm gonna be looping that, and for this case we can actually do the same thing. We can just structure directions, and we can get dr and dc, basically delta right and delta column. Okay, now with that here, all we need to do is get the new column, which is just gonna be our current row plus the gr, so for example -1 or 1 or even 0, and the same thing will happen here for row. for column, I'm sorry. So here will be co and here will be this C. Now, with that said, basically what we are having here is that we are taking, for example, 0 and 0. In that case, we have 0 and 0 because of this position. And we are doing a minus 1. Okay. Now we have a problem, because if we're doing like a minus 1 or something that is already 0, we are out of this matrix. We are out of this grid. So you can agree with me that if I'm 0 here and I do a minus 1, we are out. There's nothing to compute or to check. So that's why we need to have some boundaries. That's why we need to have a few if checks in here. So what I'm basically gonna check is if new.row is less than or greater to 0. So for example, that is okay because we are here at the position 0. Or and new row is less than our rows from up here. That means that the rows are inside its possible combination. Now we're gonna do the same thing for column. If column is greater than or equals to 0 and column is less than columns, then we are good. Now when we made the validation and check that we are inside that boundary, then we can actually check and validate if we are on the correct position or not. Okay, so all that we need to do right now is just get our grid in the position near row. So we're gonna be on the new row and the new column. And we're gonna check if that is equal or not to 1, okay? So if that's the case, then we found a fresh orange. And what will we do with that? We will be changing that matrix, okay? We'll be changing that matrix value. So all that we need to do basically is that we'll first be adding that to our queue, because now we have a new routine value. So we can just add this as new row and new call. We can, of course, decrease the amount of fresh oranges, because at the end, basically what we did was taking new row and new call and changing that to be 2. So we are actually changing the values inside the matrix, okay? So we can reduce, we can save our new position inside here, and that's basically it. With that, we checked all the positions inside the for loop, and in here, we are looping through our current queue, okay? So once that it's all over, all that we need to do is just increase the amount of minutes. Okay, let's check what that returns. Let me clear here the logs. And of course, we need to call it. So I'm just gonna do a console.log here. Gonna call oranges routing and passing the grid. And let's check what that returns. Okay, so fresh orange, sorry. So here we have fresh orange minus. All right. Okay, we have 5. We have 5 because of a simple small mistake that we have here. So for some reason, like if the oranges are not fresh anymore, so if there's no fresh oranges inside here, or let's suppose here we empty the queue. So let's suppose inside that loop, we empty the queue and there's nothing more on the queue, that is still gonna be processed. So what we can do, we have a few options. We can either do a check here and check if the queue.length is greater than 0, or we can basically just check if the if fresh oranges are greater than 0. Because if that's 0, then we can just exit this while loop. There's no need. We can return the minutes because that's over. But otherwise, we cannot do that, okay? So that would just return 4. So that's just a small fix that we need to make for this case here, okay? Now, the only thing that we need to check now is for the other case. So let's suppose we need to return -1 here. What will happen? In that case, we return 3, but that is wrong. That returns 3 because if we go from 2 to 1, that's 1 minute. And then we go from 1, and so on, okay? But now what we need to do is check here. If we still got fresh oranges or not. So if fresh oranges is equal to 0, that means there's nothing more to get written. So we can just return the minutes. Otherwise, we can just return -1, okay? Now you can see that returned -1. And that's basically it. That's breadth first search on its core. So that's a medium problem, but I'm not sure about you, but once you first develop this, you kind of get an idea of how that works. So breadth first search definitely always involves using a queue. So you should use a queue to keep track of the new written raw ranges that you have here. So here we'll be saving your indexes, okay? And that's just the main thing that you need to click on your mind when working with matrix and breadth first search algorithms, okay? So that's basically it. That's a really solid solution, but there's few things that we can make this even better. So let's suppose if someone at your interview asks you that we should not be able to change the matrix. So it would be great if we couldn't change any information inside here. You can use another approach, which is also pretty decent and pretty good. You can just use a set method and track what you have visited or not. So we can start just a visited map variable here. We can set this as new set. And here, instead of changing, for example, we will not be changing this anymore, like grid. All that we need to do is actually add that to that queue. So all we need to do is going to visit.add, and inside here we can actually add that row and column. So we can do exactly like this, row. So we can actually save that value, and we're gonna be doing the same thing for column. So see, like this. And in here, basically all that you need to do, instead of changing the value from 1 to 2, all that you need to do is check if that was visited or not. So for instance, if you are inside the boundaries, if you have 1 inside here, all that you need to do is add that here. So you'll be doing the same thing here. You'll be doing visited.add, passing exactly this, but with those new values. So you can do just like this. So we have new row, and you have also like this, new call. And you can then check here. If that all passes, you can also check like this, .has. So if we don't find that in our set method, basically we're just gonna add this here, and that's all gonna be good. We'll not be changing the grid, and it will be calculating, and that should be also return the same thing here. If I just change this from grid to normal grid, that should return for the same way as it is right now. So that's just another approach in which you save the visited positions, all right? So that's it. That's a pretty good and solid algorithm, and I hope that you like it. Now, it's pretty common that after you finish your interview, you should explain your time complexity and also your space complexity. And for the case of this algorithm, you might be thinking like, okay, I have a for loop here and another for loop. That sounds like O of n squared, right? And you might be thinking, okay, I have a while loop here, and then I have another for loop here, and then even another for loop. So you might think, oh wow, so that's O n at the third position. Okay, so that's even worse. So what's happening here? But that's actually not the case. Basically, the space and time complexity for this algorithm is O of m times n, in which m and n means the grade, or in other words, the size of that algorithm. So that's just that actually kind of means like O of n. It's not O of n because we have a matrix, but that's not O of n squared. Okay, so I hope that you like. I hope that all of that made sense to you. And no, you might. Okay, now with that all said, you might be thinking, that's cool, that's nice, but what if they ask me what is the time and space complexity of this algorithm? Okay, you might be thinking that because we are having a for loop and then another for loop here, that is a O of n squared, but that's not the case. Since we are using a queue and we are visiting at most each element on inside of that grid, inside of that matrix, the space and time complexity for these algorithms is m times n. In other words, the size of the rows and the size of the columns inside of here. So that's not O of n squared because we are accessing and checking at most each value inside of that grid, even the worst case scenario, okay? And also the space complexity, you might be thinking that it's O of 1 or something. Basically here we have O of 1 space complexity, and of course here we also have O of 1 and so on, and here we have the queue. Now the worst case is that we can actually add all the values from root and orange, so that also means that we'll be storing the rows and the grid of each value. So that's why they are both O of m times n. Okay, so that's basically it. I hope that you enjoyed this video. I hope that you understood everything that we explained it. Of course, there are different ways to solve this problem, but that's just one of my favorite ones. You can use breadth first search with queues. If someone asks you, you can even use a set value. You can actually use an array here, but I think set is just a better approach to actually check if that was visited or seen or not. So I really enjoy it. I'm making this video, and please, if you have any suggestions, any tips, or anything that you would like me to do next, please add on the comments of this video. I really appreciate when someone see my video and wanna contribute to that on any way. So please don't hesitate, okay? So thank you very much. It was a pleasure, and I see you on the next one. Thank you.